Hi everybody and welcome to your first math lesson online and this coronavirus school-free week. So the next few weeks will be a bit different. You'll have the courses online, we'll have some chats where you can ask some questions, and you have to do the homework. You have more homework than usual because there is a lot you have to do at home. And to motivate you to do the homework, I had a great idea. If you do your homework regularly and on time, you can win something very precious at the moment. I'll give you some toilet paper, and to do it even more precious, I'll even sign it. So if you do your homework regularly and on time, you might win this toilet paper here signed by me. Okay, is this motivation enough? I hope so. Good. So what I want to show you today is this here. I showed you so far how to get the equation of a sphere if you know the center and the radius. And what I want to show you today is a plane which touches the sphere. And that's basically number 35 in your green booklet. Let's take a look what we have here. We have a sphere, we have the center, the radius is 5, but that's not so important at the moment, and we have the point P 1, 1, negative 3. And what I want is this plane here. And now, as you should know, we need two things to get the equation of a plane. I'll give you some minutes to think about what are these two things and how can we get them from this situation here. I hope you all got the idea that we need a point on the plane and we need the normal vector. So the point on the plane is quite obvious, that's just P. And for the normal vector, which is perpendicular to the plane, I can take the vector from P to O. So we have 0, negative 4 and 3. And it goes, the plane goes through the point P. And now what you really should know is, come on, that's basics. To get the plane, if you know the normal vector and the point, how many times have I told you this? If I ask you this in the oral mature exam, you don't know the answer? Okay, so I take the components of n. These are the parameters of the Cartesian equation. And then I plug in the point P and here for the coordinates. So for D we get minus 4, minus 9, this is minus 13, take to the other side, it's 13. And so we have 0 times x minus 4y plus 3z plus 13 equals 0. That's it. Good, that was a warm-up for the next one. It's basically the same idea, but we just go the other way around. What we have is the plane going through the points A, B, C. We have the touching point, and I want to get the equation of the sphere. So let's sketch this here. We have 3 points, A, B, C. And we have a point P. Notice that we still need to find this here, but that's just a little detail. And what I want is to find a sphere which touches the plane at this point P. What I know is the radius, so I will need to find the center of the sphere. Of course, there's a second solution here below the plane. But the first question is, how do we get the equation of the plane if we have 3 points A, B, C? Actually, there are two ways to do it. And again, I'll give you some time to think about it. Okay, the complicated way is we take A as the anchor, we take AB and AC as the direction vectors, then you write down the vector equation, you write down the parametric equations, you solve or you eliminate U and V, and you'll get the Cartesian equation. I think this might take about 10 minutes or so. The faster way is to take the vectors AB and AC, you take the cross product of these two, and this will give you the normal vector, and then you do the same what I did here, right? And which you should know in your own material exam. So I'll speed up a bit here. Good. Now, do you remember how to get the cross product? You cover the first line and you do this times this, minus this times this. This is the first component. Then you cover the second line and you do minus 1 times negative 4 minus negative 10 times negative 6. And at the end you have to change the sign. And then you cover the third line and you do this times this minus this times this. This will give you the components of this cross product. That's minus 16 plus 48, that's 32. Then we have 4 plus, no, minus 60, that's 4 minus 60, minus 56. And then you change sign, get 56. And then here minus A plus 40, it's 32. And I reduce this vector, I'll just do it shorter but same direction. I divide everything by 8, then we get 4, 7, 4. This is my normal vector. Then I have the normal vector and the point A. Where is this A? Here. You could also take B or C, that doesn't matter. So I'll take A, that has the coordinates 0, negative 2 and 4. And get this plane. Okay, you got the first step. Now, the second step is, how do I get this Z here? I know that the point is on the plane. I have the Cartesian equation of the plane. So if the point is on the plane, I can plug the point into the plane and the equation should be fulfilled. So I take this point P here with x equals 3, y equals minus 2, and plug into here. So plug P into this. what was it? 3 minus 2. And I have the the coordinates of z I still don't know, so I just have variable z. This is 12 minus 14, it's minus 2, minus 2, it's 4. Take to the other side, z is 1. So I know P has the coordinates 3, negative 2, and 1. So far I have the coordinates of this point here. 3, negative 2, and 1. Good. Now we're almost finished. And what I still need is the equation of the sphere. And remember, we just need two things. We need the center and we need the radius. The radius is here, it's 18. Now what is the center? I need to get this point here, which has a distance of 18 to this point P. And how can we get the coordinates of this point here? If I know it has a distance of 18 to this point P. I'll give you some more seconds to think about it. Good. Could be that some of you tried to use the Hessian normal form. This works, right? We can take the plane which has a distance of 18 to the original plane, and then I get the perpendicular line and intersect this perpendicular line with the parallel plane. This works, but it's rather complicated and takes a lot of time. If you want to do it, feel free. I would do it a bit different and faster. See, we have this vector here which is perpendicular to the plane. What I can do is to start at P and I go in the direction of this normal vector 18 units. First I need to know how long is this normal vector here. The normal vector is here. Let's see how long it is. We have 4 squared plus 7 squared plus 4 squared. This is 16 plus 16 is 32 plus 49 is 81. The square root is 9. What coincidence. So this has length 9. I need to go 18 units, so I just add 2 times the normal vector and I'll get the coordinates of C. Right. Mathematically we can write it like this. The coordinates of C1, that's this here, is the coordinates of P plus 2 times the normal vector. So we have 3 minus 2, 1, plus 2 times this normal vector here, that's 8, 14, 8. This gives us 11, 12, 9. So the first center is 11, 12, 9. And the second center, I just go in the other direction, go downwards. So that's 3 minus 2, 1, minus 8, 14, 8. This gives me minus 5, minus 16, minus 7. So C2 is minus 5, minus 16, minus 7. I'm sorry, this looks a bit messy here. So I have the center, I know the radius is 18, so I need to do 18 squared, which is... Wait, do I have a calculator here? 18 times 18 324. So first sphere is x minus 11 squared plus y minus 12 squared plus z minus 9 squared is 324. And the second sphere is x plus 5 squared plus y plus 16 squared plus z plus 7 squared is 324. And that's it. So I leave it to you to do the other two exercises here. Just do exactly the same with different numbers. So, and don't forget your toilet paper. Bye. So the next few weeks will be a bit different. You'll have to Gente, não pode ficar quieto por meia hora.